The end behavior of a graph can either be the left end behavior or the right end behavior. Essentially what that means is where does f of x go as you go from x to negative infinity and x to positive infinity. We can indicate this in limit notation, and this limit notation is really important to know. It's found in calculus and the definition of what a derivative is. So you're going to be exposed to this down the road. Learn it up front and use it as your notation. What this notation means is that you're going to have the limit of f of x as x goes to negative infinity. That would be the left end behavior, and the limit of f of x as x goes to positive infinity. In other words, what is your f of x? What is your y equal to as x goes further and further to the left? Except, and the same idea to the right. If you looked at this graph right here and you just thought about left and right end behavior, what this means is as this continues all the way down and continues, where is that approaching as your x goes to the left? And that means that your f of x is going to be a negative infinity. It's going to continue without bound on the left side. If you look at the right side, or x goes to a positive infinity, what is happening to your y's? Your y's are going to continue up in this fashion, and so that means that your f of x is going to equal positive infinity. Looking at these two graphs, first of all, the question is what is your left end behavior and what is your right end behavior? Now, left end behavior, again, is going to be where your x goes to the negative direction. And so that would be this first one. This is your left end behavior. And this would be your right end behavior as it goes to the positive direction. Left end behavior, as x gets smaller, your f of x is going to get smaller as well, which means that it's going to go to negative infinity. If you go to the right, making your x positive as that continues, that's also going to go to negative infinity, and that's all you're looking at in this problem. Secondly, if you look at this problem, you're going to see that as x goes to negative infinity, your f of x is approaching some number, but it's not really clear what that number is. Same thing with the right side. As you go to a positive infinity with your x, it is approaching some number, but we're not really sure what that number is. So you have to think about it a little bit more, and a couple ways of thinking about this can give you your result. First of all, if you think about putting in a very large x, like 1,000,000 or 2,000,000, you're going to see that this minus 2 is insignificant. So it's going to be like 5,000,000 over 1,000,000, which is going to be approaching 5. As x gets larger, this number is going to get closer and closer to 5 because this minus 2 is going to get less and less significant. So therefore, on the positive, as x goes to a positive infinity, your f of x is actually going to equal 5. Now, in the negative case, you could do the same exact idea for the negatives and see that negative 5,000,000 or billion over a negative 1,000,000,000 is going to be still equal to 5, as the negatives would cancel. So both of those limits actually equal 5. Now, there are rules that you can memorize as well, because this has an exponent of 1 and this has an exponent of 1. So if you look at the ratio of the coefficients of your x's, you're going to get 5 over 1, which equals 5. A lot of times that'll be in textbooks as well. That completes the idea on left end behavior and right end behavior as x goes to infinity and x goes to negative infinity.